Right, this is a short video on a GCB investigation into a singles issue that I've resolved. I've done a couple of private videos on this, but this is just going to be like the wrap-up video. So what we got is a very, for those who don't know, this is GCBASIC. I'm using, in this particular instance, a Q26, 18F26Q24, doesn't really matter. Bit of PPS for the serial output, set the serial up. And basically, they're the constants, doesn't really matter. But basically, what I'm doing, I'm going to print out a single value, and that value is a variable called UPC. And I want to print on the screen a range between 3 and 9 using a routine called single to string. Actually, if I press function key F1, why doesn't that come up in here? Single to string. It's in there. Look. So it's the function and in the last video, private video, I said that that was broken. That routine was broken, and I've been working through that very slowly. If I go back to the terminal, you can see in a moment it's going to pop on the screen. I'll just power the cycle of the chip up, and there you go. It's putting it on the screen. You might not believe me. That's always the case. That's because you can't see it. I didn't put it on the terminal. There we go. This is what I've got. That's good. I haven't set the camera up. There we go. Look. I've got one of these. Look, okay. It's a GCBASIC board. I use them extensively for prototyping and testing. And there's a Q24 here and a serial connection at the back. And if I power cycle it, let me bring that in. If I power cycle it, the terminal will update, and it's obviously doing it because if I change the range 2 to 10, I don't know, 2 to 255, it will just stream that past at high speed. I mean, I'm got a very fast baud rate. It's not important. That's not the issue here. Okay, the issue is that it's got to print what it said it should do on the screen. Fine, that works fine. Great, isn't that wonderful? Watch this. So that's Q24. Now, the only reason I've changed the boards here, by the way, is to make it easier for me so I don't have to keep fiddling around. Okay, now if I'm correct, C6, we got some power on it. Got some power on it, good. Back into my source program. I'm just going to change the chip at the top to a 18F14K22. I'm just going to comment out that subroutine, the call there. So I've just changed the chip at the top there. Oh, you can't quite see it. 18F, there you go. I commented out, called the PPS. And what else I need to do? I'm going to put that back to 9 and 2, that's fine. The issue there is that if I'd left it in that big range, then it would have been an issue. Right, this is because I've just ported one thing straight across. I'm just going to take those off. That's because I took it from a Q24 program. Okay. Back into the terminal. Should be able to see the terminal now. Oh, very fun. I've had a problem on K22s. I will have a look at that later on. It's found the chip and it hasn't programmed it. Is it because I've got a potentiometer on that line? No, looks okay. Oh, I've done something wrong here, haven't I? Just starting up PitKit Plus. I've done something wrong. I've either typed the chip name wrong at the top. Control V. Let me just see if I can do it by hand in here. Look at that, that's interesting. Oh, that's a low voltage. I've got the wrong voltage. I had the wrong voltage set. In the terminal, let's look at the terminal now. Was it printed? Let's have a look at the power cycle. I'm just going to open the data sheet. F14K22. Open up the data sheet. It's quicker to do it in there than anything else I know. And in here, I'm just going to have a quick look to see what port the transmits on. Oh, it's on B7. That's why it's not showing anything. B7, I'll just change that to B7. Now, that shows 2 to 9, which is correct for that chip. Good, we're getting somewhere in sort of resolving this. Now, that is all working. That's because I have changed one of the libraries. So I'll go into the full screen mode, get rid of that. So over in system.h, I put in ASM bank cell. Okay, so here is what I've added in, and I'll explain what the issue was. So inside of the string handler, it was constantly asking, of course, if a number was bigger than another number. And that's all handled in this routine called sci system compare less than single. Compare less than single. And this is all based, this whole routine, what I'm going to show you is based upon published articles by Microchip. So, and essentially what we do is we take a variable on single temp A, simple temp B, and compare the two, and the output comes back as true as false in single temp X. So it's a really simple way of having a generic routine, and it's used extensively, that approach. So some debugging here, and essentially what the first thing it does, it just converts the IEEE 574 numbers into the microchip format for the numbers. Very simple, very fast operation. And then it calls a routine called underscore sys, compare less. Now that happens to be a macro, so it's going to put that. Is it cool? Is it a macro? We'll have a look. It calls that routine. And the problem is that the bank was not being selected correctly upon exit. And it took me a long time to figure this out. Then as it exits out from here, it sets up, it uses the return value and sets things to true or false. So here is the routine. It is a subroutine, and it's based upon the app note 006600.pdf. And essentially all it does, it sets up the memory. We don't need to go through that because that's just a memory set. Okay, just sets up the memory, creates the memory block, and then it goes through exactly, you know, the code is essentially unchanged from that app note. And so it goes through using these arguments of A's and B's and temps, goes through, and all that's been set up, and it was all correct. And what it does essentially is it returns here. It says return a literal of 0 or return a literal of 1. Goes through that, doing its stuff. And so it calculates whether that number is less than or compares to it. If it's not, it sends a 0. If it is, it sends a 1. However, that's not, I wanted to leave that code exactly as it was because it's reference code. I didn't want to change it. However, when this exits out on the some of the 18F chips, the bank cell is not set correctly because of course this isn't the right bank cell. It doesn't. The bank cell is changed throughout this process. And where is it changed? It's changed over here in this app note. This app note that I wrote stupidly, yeah, me. It's a macro. It just allocates a load of memory to the variables spoken, you know, that are referred to in the app note, and then finally at the bottom it sets some exception flags, and that exception flag changes the bank cell. And because the other routine wasn't resetting the bank cell correctly, the bank selecting the right bank, the code was getting overwritten. So I'll show you. Comment that out, save that, back to that program, back into this mode so we can see things. Hopefully it will program it this time. That's the reset. It's stuck on 2. But the symptom was more complex than that because it was overwriting variables. And I should have spotted that earlier on. So the fix is doing, and I'll explain why it goes wrong. I can show you why. GCBASIC knows how to create and manage the whole of the memory environment. At the bottom of this routine, I should have spotted this. In the assembler, if I come into here and look at the bottom of this routine by looking at the generated assembler, at the bottom, this is it exiting out. So if we look at the code, the system code, it says the last two in here is return a literal of 1, return a literal of 0. So we know we're looking at the right piece of code here. Look, here we go. Look, it says it there. And then as GCBASIC was managing the memory, it says, oh, as I exit from here, something has changed the memory. I just need to reselect bank cell 0 so the rest of the code is fully managed. I had failed to spot that. Now the way the right a method of doing this would have been coming into here, and at every instant in here, I could have gone in here and said, right, okay, bank cell 0, return 1, bank cell 0, 1, sorry. I could have put the bank cell in every case. So in here, I could have gone, BTS, right, okay, I need, oh, wait a minute, I can't do it in there because this is a BTFSS. Oh, so that would have screwed up if I put a bank cell back in there. I could have done it cleverly. I failed to do it. So the easy way to fix this is to put the bank cell after that call, like I have. So it calls out to this. Where has it gone? It calls out to that routine, does the comparison per the app note. And then upon return, it sets the bank cell quite correctly as GCBASIC had assumed it had been set because it assumed correctly. If I now program that, that's the run from the last, and all of a sudden it's correct because the bank cell was not correct. Resolved. Enjoy. I didn't. Took 4 days to fix it.